Good afternoon, everybody. Welcome to our Sunday afternoon West Coast U.S. time. And I am your host, David Livingston. Thank you very much for tuning in. And one of our very, very favorite longstanding guests is our superstar with us today, Dan Adamo. And I'll say more about Dan in just a minute and tell you who is consisting of our wisdom team today. So we have Zimmerman coming up on a show. I believe that is Tuesday, and we have our friend. Let's see, on next Sunday we have Dr. Kathari. He wants to talk about his presentations that he made in India and what the Indians think of some of the things he said. Our friend in Italy who wrote the book Extraterrestrial Life, We Are Not Alone, Dr. Del Popolo, if I got his name correctly, is with us on Friday, and he has 36 slides that he says proves that we are not alone. So that'll be interesting. He is an amazing physicist and an astrophysicist type of guy. Antonio Del Popolo. So that is next Friday. Dr. Ethan Siegel, who many of you may follow and may know, is with us Tuesday, January 27th. And the great journalist Sarah Scholes comes back to close out January for us. Um, so there's more, and you can check it all out on our newsletter. A couple of other quick things. Remember that the Space Show is a 501c3 nonprofit listener user supported radio program, and we appreciate and do request and need your support. So PayPal is always the easiest way. There's a PayPal button on the right upper side of our homepage, thespaceshow.com. But if you're a Substack user, Substack has its own support, subscription, and contribution plan. So you can use that with Substack, which is Dr. Space, DOCTOR space .substack.com. Or you can just click on our Space Show link to spaceshow.com and go use PayPal or Zelle or send us a check to our Las Vegas address. We also do sponsorships, and sponsors are $500 a year. And, you know, we're sort of phasing out the website, but for now we still do banner ads. But on Substack and other medium, we're not doing banner ads, but you do get shout outs on the Space Show. And I want to spend time with Dan talking. So I'm going to do the shout outs at the end of the program today. But I do want to welcome to the team that is with us. So in the right corner in the blue is Marshall Martin. And in the left corner in the rust-colored shirt is Bill Gowan. And in the center of the octagon is Peter Foreman. John Hunt is sharing the right corner. And John Jossi is sharing the center of the octagon. And our superstar for the day is Dan Adamo. So he's been a guest many, many times on the Space Show, never by Zoom. So we're all getting a chance to see one another for the first time. But he managed rendezvous and shuttle flights for what do we say, 3 centuries for NASA, something like that, Dan?
60 is all.
And then he retired. You voluntarily retired, right? You weren't retired out. And he's been in private practice consulting ever since, and he has some pretty strong opinions about the way Artemis plans to return to the moon with people, especially the kind of orbit that they are using, which, as I understand, is essential because it's the only orbit that SLS can reach, which sounds a little weird to me, but then orbital rendezvous is not my specialty. Maybe there's a reason why they would make a rocket that could only reach one sort of weird halo lunar orbit. I'd like to know the reason for that, Dan. Maybe that's a good opening question for you.
It
Why
is.
would they design a heavy lift rocket that could only get to the moon in one convoluted, crazy orbit?
Well, let me just correct that a little bit.
Okay.
Uh, SLS on Artemis 1 sent an Orion spacecraft into a totally different kind of orbit. In fact, an orbit that I would advocate is a much better waypoint um, to interplanetary space or from interplanetary space because it's known as a distant retrograde orbit. And I can bring up some plots of those if we want to have a more extensive discussion on DROs, as they're called, lunar DROs. But where they differ from the nearly rectilinear halo orbit, NRHO, that we're actually planning to use for humans flying to the moon. We won't go there with Artemis 2, but we will, as I understand it, with Artemis 3 when we actually try and land on the moon. But I wouldn't blame SLS so much. In fact, with these initial Artemis missions, I'm not sure if it goes through Artemis 3, but when we launch an Orion to the moon with an SLS, even the Block 1, which has a horribly mismatched upper stage, which let NASA close a budget, um, uh, it's not at all well matched with the core stage with the solid rocket motors and the refurbished shuttle main engines down at the base. Um, the Block 1 upper stage, I believe called the uh, interim cryo upper stage or something to that effect. It's just a cut and paste from a Delta 4 upper stage. And a Delta 4 core stage is totally different than the SLS. So even with those mismatches, there was enough payload mass margin on Artemis 1 that they flew a whole bunch of little payloads out to the moon that weren't involved with the primary mission at all. And I believe that's the case with Artemis 2 and probably Artemis 3. So you've got actually more performance than you need to get an Orion to the moon, even with a crew in it on the SLS. And what the bottleneck on performance is that we ought to make really clear here, and other folks feel free to jump in if you've got another take on this than me, is the service module for the Orion. You could eat up all that extra payload mass that the SLS is capable of and maybe upgrade and stretch the Orion service module. And then you could get into some really interesting orbits from the operational point of view, ones that are much lower in average altitude above the moon, that would have shorter period and thereby remove this really nasty constraint where the NRHO has a period of about a week, plus or minus. And that means that when you commit to landing on the moon out of an NRHO and the CEV, the Orion, is left in that orbit, that's your ticket home. And so you are stuck on the moon or in some kind of extended rendezvous if you can't adhere to a 1 week stay time on the moon. You're stuck there for a week, basically, before you can even get to Orion and start on your way home. So it's a sobering proposition.
Yeah, so, um, but that's the policy of record. So, um, so,
Program of record, yes, sir.
so what are you suggesting, or is there a viable suggestion to do something that might be a little safer? Or maybe we should say as what do you think, given your flight experience, delays, whatever happened during shuttle period when you were there? Um, what is your experience of things not happening on schedule?
Well, yeah, better, faster, cheaper will kill you every time. And you know what's sad is that um, you lose hardware at a minimum, and maybe some crew um, in the worst case, and you wind up no better off than if you'd just been diligent up front and not forced that Challenger disaster or forced um, uh, the crew to fly a complete STS-107 without even looking to see if the wing had gotten damaged. I mean, that's just irresponsible stuff, and we're going to see more of it. I see it with the current program of record. It's just insane. And the reason I feel qualified to say that is that we're talking about before we can even do translunar injection and leave low Earth orbit and head for the moon with uh, a human landing system. So I haven't even sent crew out to the moon yet. We have to do something like 10 to 20 heavy lift launches, each of which does a rendezvous with a propellant depot and transfers propellant into that depot to fill it up. And filling it up may not be a very easy proposition. You can't just say, oh, I need 12 flights to do that. Because if any of them gets delayed for whatever myriad reasons that a launch can get delayed, and boy, have I seen a few. I remember one mission I replanned easily 24 times because of one launch delay after another. Um, with all those delays, you're going to have cryogenic boil off in the propellant depot. And who knows how many missions it'll take, how many flights it'll take to top the thing off sufficiently so that by the time you do one more launch to get the crew on the way to the moon, you have a fully fueled lander. And that's just crazy. I would much rather, all the research I've done on in-space propellant depots um, leads me to the firm conclusion that the best place for a propellant depot is at the end destination. It's sort of like the way airlines work, right? You know, if you're flying a long haul flight, you don't bring propellant, or you don't tank up after you've climbed to cruising altitude and then expect to have an efficient flight. You take all you need to get to the end destination, you refuel, and then come back or go on to wherever else you're going. So with space flight, it's even more the case that you've got to do all you can to have a nimble architecture that gets you to the destination, and then you can tank up for coming back or going on to somewhere else or whatever. And that's why I personally, and of course, I'm throwing schedule to the wind here, and saying, well, if the Chinese get there in 2030, so be it. But in the meantime, I'm going to have built a robust architecture that is responsible. And that architecture I've been advocating since the closing days of Constellation and that last Augustine Commission circa, what was it, 2009, was it? 2010, something like that, is lunar surface rendezvous. And in effect, you just launch heavy lift vehicles to the moon, one launch per translunar injection. Don't have to wait around for propellant depot work in low Earth orbit. And you just keep launching stuff to the same landing site on the moon, cargo only, until you've got enough positioned there that when a crew lands nearby, they've got a ticket home. And that's where you do all your rendezvous, is right there on the lunar surface. And then you wind up with, if you want to leave now, right now, and you didn't plan, you plan to stay a week, a month, whatever, and you want to leave right now in the middle of the night, maybe, no problem. It's all there ready to go. And you have no constraints on getting home where you have to loiter in low Earth orbit or a low lunar orbit, where you wait for a plane to align relative to the Earth, or have to do extra burns to change planes and all this kind of stuff. That's all down the tubes. You just launch and get into low lunar orbit and maybe do one orbit to check out your systems. And then on the far side of the moon, you light up and head back to the Earth because you're in the right plane to do that from the launch. And that's the way to have a real lunar architecture. Now you're operating like airlines do.
So who's listening to you?
Well, I submitted an extended white paper to the Augustine Commission, and it's been an uphill battle ever since.
Well, that was decades ago.
Yes, yes, it was. That was just after I retired in 2008 from conventional employment, and so I was free finally to give vent to my creative juices and do studies that wouldn't get my employer in trouble with NASA or Congress or who knows who. So that's what I advocate. And it was inspired by Constellation's mantra, which was land anywhere, leave anytime. And Mike Griffin would be happy to quote that to you again. I'm sure that is the ultimate architecture that enables that kind of responsive planning. What we have now is like, well, if you like Rendezvous, and I do, you're going to see a lot of it. In fact, you may see a dozen or 24 or maybe more rendezvous before you even leave low Earth orbit. So
I would ask the question here that obviously you have colleagues that have similar knowledge about the problems, maybe not the answer you have, and yet what they're doing right now has a lot of problems in it. So you kind of wonder, why are they doing it this way?
My colleagues with the knowledge, okay, I've remained in touch with a number of them, and even have made new friends in flight control, particularly in the space station side, since I retired. And they have the same mindset I did when I was working in mission control, which is when somebody says jump, you say how high. That's your only question, right? Your challenge as an operator, as they call themselves, is to get the job done, and somebody else define what the job is. Unfortunately,
let me step in for a minute because I should have given you a proper introduction, Dan, instead of joking around because we're old friends. But for many of you who are listening and you don't really know who Dan is, and I'll let him supplement, but he managed rendezvous and shuttle orbits and all of that for NASA for what, 25 years, 20 years?
With a lot of help from people in flight design and people in navigation, and
But
the
you
whole
were the
dynamics
guy.
team.
You were the guy, and they didn't have AI, and you did have computers, and they did have slide rules. Did you do any work on a slide rule?
Let me give you some perspective. I never brought a slide rule on console to do actual work. I did have PCs, I did have hand calculators we were permitted to use. But when I first showed up to Mission Control, I was using the same consoles they used in Gemini and Apollo and Skylab. And black and white monitors that would show one TV image, not a windowed system like we have today. Although I did have PCs and mini workstations toward the end of my time, 2008 timeframe, back when I started flight controlling circa 1990, all we had was a mainframe, the mission operations computer, which wasn't the same model of IBM mainframe that they had in the Apollo era, but darn close kind of architecture, right? You had this mainframe. And a limited number of TV channels that you could uniquely access to display on your black and white monitor, just like Apollo. just like the MTV footage.
So, listeners, when you hear Dan talk about orbits, he was the go-to guy that helped create this whole industry. So he does know what he's talking about, whether you like what he may say or not, or it doesn't match with your fantasy or not. I really can't help that. But if you talk about bringing numbers to the game or doing the hardcore analysis, this is the guy that knows how to do that analysis. And if you've ever picked up an orbital dynamics textbook, you'll wonder what he's made of because you probably won't understand half of it unless you really have a mind for that kind of stuff. So
Well,
that is
well, I
his
like to think I'm
experience.
one of many, David. There's an astrodynamics expert in virtually every new space company, and NASA's rife with
Well, yeah,
astrodynamics
but
experts.
you pioneered it. So before we continue on with lunar orbits, we've got four contenders for private space stations. And you took shuttle to the space station, you docked it, you rendezvoused it, you did all sorts of things with it. Give us your take on the private space stations and how they will fulfill what the ISS does, or maybe surpass the ISS, and how will docking and rendezvous and orbits and all of that work with the privates.
Oh, I think it'll work great. And in fact, they've got right now um, much more payload capacity um, per launch to one of these low Earth orbit space stations than the shuttle enjoyed, because the shuttle was reusable and reusable in the sense that it flew back like an airplane with wings and stuff. All this dead weight that could have been payload weight, if that was your mission, to deliver maximum payload up to a space station, or bring some back from the space station. Now, shuttle could do all that, but it could have done so much more if it wasn't reusable with wings. If it was just going to come back down, it could have come back down with a habitable crew volume of a few hundred cubic feet kind of thing. It could have brought so much more mass up there. Think of the shuttle. Sorry to regress to English units, but that's what I was using during the shuttle program. Easily over 210,000 pounds was the gross weight inserted into a stable orbit with a shuttle. And that's not too far from the Apollo days either, where they're putting like 250,000 pounds of gross weight into low Earth orbit. But the shuttle's payload carrying capacity in the bay was rarely over, I think 40,000 pounds. For one thing, you had to worry about bringing it home if there was an abort. If you couldn't deploy your payload, you had all that mass when the wheels hit the runway, and hopefully it was a net center of gravity that was in this little shoebox-sized envelope that permitted flight control to actually fly an entry without going ass over tea kettle. So the shuttle was an amazing flying machine, and even in orbit, with close-in proximity operations and stuff, it was an amazing flying machine, and it was reusable. But if you're talking about what is going to make these new space stations earn a profit, um, it's mass to Earth orbit, and then probably a little bit of down mass too, that the shuttle could do. Again, we could bring a whole bunch of mass down, but only within limits. If you put a whole bunch of stuff in the crew station, um, up
Mm-hmm.
there in the front of the shuttle, near the nose,
Right.
in the pressurized volume, you had to start talking to the propellant officer. We need you to hold back orbit maneuvering system propellant in the aft pods on the other end of the shuttle to act as ballast to keep that center of gravity in the shoebox size envelope. I mean, or we'll lose control coming home. Too much of a good thing. And I'm sure, vehicles like um, Dragon uh, and others in new space, they'll have these kind of operational limitations too. But the shuttle was really subject to quite a few. So that's the kind of thing you're gonna see with some payload transport, even up to low Earth orbit and back down again.
Yeah, the
So,
Starship would probably suffer from that kind of, I mean, sensitivity as well, right? I mean, there's a lot of depending on what's in the front end of it, it may be a challenge to get it back in successfully.
That's very true. I mean, think about what's going on in a starship. It's getting rid of all its propellant practically. And so when you come back, maintaining control through that entry that we've seen in some of these test flights is going to be a real challenge. If you don't have the right center of gravity, if you have too much mass. Um, Starship is going to be an amazing vehicle too, but I'm not sure it's the greatest lunar landing uh, option. I think where the big bucks in Starship are anywhere in the near term is using it as a hypersonic transport, you know, point to point on the Earth's surface. Anywhere you want to go, Mr. Businessman, we'll get you there in under 2 hours. And
Maybe
probably with a lot of luggage.
do you have a favorite of the private space stations?
I really don't. I don't know enough of them. I really like the inflatable HABs that one Bigelow has put up on the space station. I mean, think how much volume that's got. And I think it's been up there for years and it's still passing leak checks the last I heard. So Kevlar is pretty amazing material.
Um, what's wrong with lunar orbits of today, or what's good about them, which is really why you're here and
Yeah, that's
what
true.
your charts and graphs are all about.
Yeah, do you want me to go screen sharing? I think
Well,
Marshall has a question. Why don't we
Yeah.
ask him
Uh,
first?
yeah. Let me ask. You were earlier talking about the uh, problems of launching and making sure everything was ready for launch. And the first thing that popped in my head was, oh, yeah, the weather problem. And then the second thing that popped into my head was solar flares.
Yep.
Right at the moment, we're talking about solar flares hitting X10, which would pretty well fry anybody in space if they weren't under the Van Allen belts.
Mhm.
Is there any more major
Oh,
input to launching when you want and where you want, et cetera, et cetera?
I'll put my sim supervisor hat on because Lord knows I've been to enough ascent simulations that got scrubbed or near scrubbed, that kind of thing. Another good one from the environment is meteor showers, meteor storms.
Oh,
That's
yeah.
delayed launches in the
Mhm.
past. And the Sim Soup's favorite is um, unauthorized ship in the launch area. People love taking little pleasure boats into, see the launch real close up and personal. And it's like NASA won't launch under those conditions. So,
Mhm.
um, and something similar to meteors is collision avoidance. That's something that the dynamics team of any of these launch providers is going to check and see
Mhm.
against the entire catalog that we can track, even the unclassified elements of it. If you're going to launch into something that's uncomfortably close in terms of a close pass of something that's already up there. And that's,
Mhm.
that's going to become more and more difficult. It's just a good thing that constellations like Starlink are, up there by the time they get into operational position. They're up there like 400 kilometers. So it's not like you're going to launch into it because generally you're more like 200 kilometers when you launch, when your powered flight is
Mhm.
over, you're more like 200 kilometers. So you're below most of these mega constellations we keep hearing about. Chinese are going to put one up and, Jeff Bezos is going to put one up and it's getting crowded up there. Would you excuse me for a second? I'm going to Uh, it's getting to be a real sunny afternoon here, so I'll hopefully show up okay. Yeah, with the shades a little more attenuated. So hopefully that answers your question or gives you a little
Mhm.
bit of a feel for it. I mean, anything can come along to delay a launch. And then, hopefully these operations with transferring propellant are going to work, without much of a hitch, that they'll be reasonably reliable. But that's an amazing process. If we can prove that operationally with Starship, if SpaceX is successful this year, that is going to be a real game changer.
Mhm.
But again, I really don't like the architecture. I'd much rather see these heavy lift launches get at a low Earth orbit, check their systems out. If everything looks good, it's just cargo only. So not
Mhm.
much risk and just lighten up and heading for the moon. And then the depot that you're going to deliver to is at least in cislunar space, if not a specific location on the surface of the moon. And that's where you're going
Mhm.
to cache all these goodies. To enable exploration, to enable the return,
Mhm.
all that.
Well,
Ideally, lunar surface rendezvous is the only rendezvous you do.
well, you were talking about the current orbits such that they can only launch off the moon about once every 6.5 days, I think it was.
Yeah, everything's
And
tied to the orbit period of where your ride home is, right?
yes, and that's the big. Uh, I usually use the word stupid flag.
Yeah, why don't I screen share? And I think I can see most of you even while I'm screen sharing. I'll screen share and I'll show you what this orbit looks like
Mhm.
um, to scale. Let's see, that one, share. And then I'm going to go full screen on my display, which will hopefully make this a little larger. And then you can adjust your individual displays at home if you're watching, so you can zoom in to your heart's content. But this is a quick write-up that I did several years ago. You can see late 2022. Of the Capstone mission, which is a CubeSat that weighs only 25 kilograms. And this is how it launched into this yellow orbit around the Earth. And the sun is off in this direction. You can see from the gray shading here. And then it just progressively raised its orbit. Even though it has a very little amount of propellant, it had an upper stage that had a lot more propellant than it could carry. And that upper stage was doing all this heavy lifting to finally send it on this blue trajectory out to the Sun Earth L1 point, which if I go to, oops, got a window here. The next page shows its kind of circuitous path. Here's the Earth, little tiny pinhead, and here's the moon's orbit to scale, and it goes out to Sun Earth L1 and floats around there and gets some neat perturbations that cause it to come in very tangential to the moon's orbit and minimize the propellant. And this time, Capstone had to do the work. Minimize the propellant Capstone had to expend to get into a nearly rectilinear halo orbit. And at the time I wrote this, they were actually flying this approach to the moon and then firing up their engine and getting into this nearly rectilinear halo orbit. You can see how it almost closes, but there's little variations. Um,
Mhm.
and so let's stop there and just see if there are any questions you have about this orbit.
Uh, is
Far out. How far out is that Sun Earth L1?
Oh, about 1.25 million. So 1,200,000 kilometers.
Okay,
It's,
five
it,
times the Earth moon distance,
and
basically.
that's all to scale in that previous diagram, which we can go back to if you need to.
Gotcha.
Mhm.
Gotcha.
Yeah, that's all
um,
to scale. And that
my,
go ahead.
yeah, my quick question is at what orbital altitude was Apollo? Because they seem to have like 1 hour to launch, as I recall, off the moon and rendezvous.
So you're talking orbit altitude in low Earth orbit or in lunar orbit?
The lunar orbit.
Okay.
It was
Lunar orbit,
fantastic.
yeah, lunar orbit, by the time they got to a rendezvous phase in the lunar landing mission, they were pretty much at 100 kilometers. And the orbit period was 2 hours.
2 hours?
Two
Okay.
hours. And the cool thing about Apollo is they were on the other end of the performance spectrum with their service module. That service module had an engine that was designed back in the early days, or spec'd out in the early days of Apollo, when they thought we were just going to land on the moon and take off and do it all with that engine. So there was no rendezvous, and they in effect did have lunar surface rendezvous, but without the supporting flights. Everything had to be carried with that one flight, that one launch. And the service module for Apollo had a 22,000-pound thrust engine. And that's for a command module that weighed, I think, about 12,000 pounds. And that's, of course, Earth poundage. So on the moon, it was even a better thrust to weight ratio. And the Apollo service propulsion system was capable of doing huge plane changes, so that if you landed at a mid-latitude site, like Apollo 15 was a great example up there in Hadley Apennine, where they were, close to 45 degrees latitude. Of course, the moon is rotating eastward like the Earth does, and that rotates out from under the orbit plane. But instead of doing it at 15 degrees per hour, it takes days for it to go 15 degrees. So the Apollo command service module sitting up there in 100-kilometer orbit could go and do a big plane change and go back over the landing site repeatedly. They would do it sometimes even before the lunar module was ready to lift off and rendezvous. And they would do it such that there was an option to do an emergency early return to command service module. Maybe they knew a solar storm was coming and they needed to get home lickety split. They might not have had that kind of warning, but today they very well could. We've greatly extended our ability to predict space weather. But, with the current architecture, you can't take advantage of that very much, because you're stuck. At best, you're stuck either on the moon or in some kind of phasing orbit that tries to maybe, if we look here, everyone can see my pointer okay? You can see that you might be able to launch from the moon, get into low lunar orbit, and then raise the altitude of that orbit so that you're in a 1 week period kind of NRHO. But where's the ride home? Whether you're using a independently orbiting Orion, or one that's docked to the lunar outpost, the lunar, what do we call it? Gateway. It's in some position around this orbit that may be on the other side of the orbit, and you've got to wait many days to catch up with it. You might have been better off just staying on the lunar surface and waiting for it to come around again, so that you could catch it. So that's how you get stuck in this trap. This is anything but a 2-hour orbit like we used to fly in Apollo. This is a 1 week orbit, and it is sobering.
One thing, it looks like the service module doesn't have enough delta V with this Orion system. Was there some limitation why we had to make it that small of capability, or so that you could do something more like actually go back to what they did on Apollo? That is, go into lunar orbit, low lunar orbit, which this system doesn't have the capability for.
Yeah, see, unlike Constellation, where we started with, and albeit just for a few months, started with a clean slate. Okay. And so, kudos to Griffin and company. With that's the constellation program. With Artemis, we started with a bunch of politicians again. We had the Space Launch System, aka the Senate Launch System, and that was like, how can we maximize reuse of space shuttle parts? And that's tying a millstone around your operations neck. Um, that, and with the service proposal or the service module for the Orion, basically some folks that weren't very imaginative about what it takes to fly to the moon safely, responsibly, said, well, this Orion thing, we were going to use it as the crew return vehicle from a trip to Mars. And for that job, it's a free flying spacecraft after getting the crew to this interplanetary transport. It's a free flying vehicle only to do that rendezvous and to jump off the transport and get into the entry corridor for Orion's return to the Earth. Now, that was a bad ops concept there right off the bat, because what are you doing hauling a heat shield all the way out to Mars and then coming back to Earth only to use it at the last minute? I mean, that's just insanely expensive. Plus, it makes for an interplanetary transport that you jump off of it at the last minute and throw it away. That's insane too. And to top it all off, you're taking a crew that's been out in interplanetary space for almost 2 years, subjected to weightlessness, or at best 1/3 gravity on Mars, assuming they actually land on the planet. And then you're going to put them in the CRV, the crew return vehicle, pop off the interplanetary transport, and slam into the Earth's atmosphere at something like, geez, I'm not even going to estimate what it is. The number's not right in my head, but going much faster. Now the number's coming back. Going much faster than the 11 kilometers per second you would go coming back from the moon, right? That's about what Artemis I experienced coming back, and that's typical, plus or minus a very small amount actually of what your terminal velocity is hitting the atmosphere coming back from the moon's orbit. With a interplanetary mission, you're going at least 12 kilometers per second, maybe 13, 14 kind of kilometers per second. So not only are you coming back faster with higher heat loads and higher mechanical loads, right, as you hit the atmosphere going that fast, but you're totally deconditioned with the kind of vehicles we've been talking about that don't have anything beyond a treadmill like we have on space station, where if you're diligent and exercise 2 hours a day, you can work into some kind of ability not to conk out when you try and stand up in 1G when you come home. Here, you're going to put them in, plus 10 Gs for I don't know how long. You'll be lucky if they don't have cardiac arrest, right? After, nobody's run this experiment, even though you could kind of do it with space station. Stay up there for almost 2 years, and then get in a vehicle that takes you into a high speed trajectory that hits the atmosphere at 12 kilometers per second. I don't know. And see if anyone survives. I don't know. That's a real problematic kind of nasty experiment to run. But no one's even attempted anything like this, because the Apollo missions that came back at 11 kilometers per second, those crews, the guy that stayed in lunar orbit, he'd been weightless for something like, maybe 12 days, 14 days. That's nothing compared to what we're talking about, the level of deconditioning. So that's what Orion's original mission was. And they just took that mission and plug that square peg into the round hole of a lunar transport. And so you wound up with delta V that was maybe a few hundred meters per second kind of capability. And then we told the Europeans, okay, this is what we need. And we see that you've got this vehicle that can pretty much do that already, that was supplying cargo to the International Space Station. Why don't you go repurpose that, and we'll give you all the specs and interface requirements for the Artemis program. And that's what we wound up with. So we didn't start with a clean slate. As far as I know, we didn't have any people in my field of astrodynamics saying, and mission planning, saying, hey, you really don't want to get into these long period orbits. Yeah, you can get down to the moon surface or back from the moon surface pretty cheaply, but look where you are, or where you had to go to get here. You only have a window for rendezvous that's once a week. And yeah, you can get into this orbit with Orion. You can also get into a much higher altitude circular orbit, as they did in Artemis 1. That was up there at 70,000 kilometers, which in this diagram you can see that's about where the apocynthion of the capstone orbit is, very close to 70,000 kilometers. But it's anything but a circular orbit. And as you can see, things don't hang in there very reliably with this orbit. When you're out at 70,000 kilometers, technically you're out of the moon's gravitational sphere of influence by plus or minus about 10,000 kilometers. And when you're out that far, the sun and the Earth can tug on the orbit and perturb it. And that's probably what we're seeing here in the orbit's inability to exactly close. Not too serious, because down at periapsis, nearer the moon, maybe 1,000 kilometers or so above the moon, things closed up pretty nicely in this case. But let me just show you what happened when I tried to play this game, starting in one of the early capstone orbits and not doing any course corrections. Okay, I'm just coasting out there with the moon's gravity, the Earth's gravity, and the sun's gravity, playing their game. And look what happens here after just a few orbits. So maybe a month or so after this November starting time, up there in January 2023, I just go floating off, where I may wind up hitting the Earth, I may wind up hitting the moon, or just sailing off into interplanetary space with the right lunar flyby. No telling what happens. You hear from NASA every once in a while that a nearly rectilinear halo orbit is a stable orbit. It is anything but that from a dynamics consideration. And here's another case where I went and didn't last very long, matter of weeks or months. And that case of hitting the moon is even more likely if you're talking about a realistic spacecraft, whether it be Orion in its standalone mode or Orion docked to gateway, because these are human-occupied vehicles with habitats that have pressurized volumes in them, and when occupied by crew, they're doing urine dumps and who knows what kind of trash they're generating and needs to be vented or dumped overboard somehow. And those perturbations can drive your orbit right into the ground, literally. And so every week or so, you better be prepared to do what we used to call in the dynamics operations world a critical engine burn, where the vehicle or the crew is threatened if you don't pull it off on time.
So Dan, let me stop you for a moment. If we make the assumption that you are not the only mission qualified orbital expert on the planet,
I am not.
why and what was the reasoning that all of this was planned this way, or do they pay no attention and dismiss what you and practically every other person coming on the space show is saying these days? What is the justification for what they're doing? Because if I were to add up all the space show programs, say over the last 3 years, with pros and cons on this stuff, the con list would probably be pretty huge, and the pro list wouldn't, I don't think, would have anything in it or very little in it.
The
So,
pro is, given all the political and schedule constraints, we managed to close on performance just barely. We got into an orbit that Orion could just barely make it into and out of, and that if you have some kind of really capable lander, then you can transfer the crew into that lander that you've sent out there on its own with its own launch. You can get in that lander, land, and then take off and re-rendezvous. And all those drivers had very little to do with astrodynamics or sensible architecture and mission planning considerations. Very little.
so their track record for making critical political decisions is not very good.
That's
So,
right, because politics has invaded space exploration, and it always was there, to some degree, because who's going to pay for it? A bunch of politicians, right?
yeah.
And even if you're SpaceX, who's really paying the bill? Other than the business they've made of getting people into low Earth orbit. If you're talking real exploration out there, out of low Earth orbit and off to the moon, there isn't a business case to be made for that yet. And certainly landing on the moon and thinking about landing on Mars, you've got to have some politics to raise the money.
So why does a mission planner or engineer or orbital specialist sign off on all of this? Because I'm assuming they have studied history, they've studied lesson learned, they at least have some inclination of what you're talking about. So if they're and you can't tell me that they're all unethical bastards because I don't believe that. So
Well,
there's a
no,
gap here that I'm failing to understand.
well, let me just take you back to that remark I made earlier. When you're a troop in the mission operations game, the only question you ask when somebody says jump is how high. Um, you are going to make the system work as best you can because you're not in the business of defining the system. Um, would that you were. And like I say, the last time NASA operated with a clean sheet of paper on lunar architecture was back there in the inception of the Constellation program. So you're talking before I retired, even in 2008. That was I can remember that being at Johnson Space Center and hearing about this, whatever it was, 90-day study or something like that Griffin had commissioned, and that was great. I just wish it had been longer. Think if we'd spent several years fine tuning a really good architecture instead of being in a hurry back then. What we were trying to land on the moon by 2015 or something. Man, it's turned more into like 2050 because by the time that's what it's going to take to start over again and hopefully with a clean slate come up with something that's really responsible. It's going to be 25-0 before we're responsibly landing on the moon with a sustainable program.
Now, does China have a better, safer way of doing it from what we know about China?
It's, I think, a little more limited, but yeah, if you want, I'll go to that attachment that you put on your website when Griffin came to speak. It was part of his testimony to Congress.
Okay.
You want me to call that up? That has the Chinese architecture as best we know.
Okay.
While you're pulling that up, I'll just
Yeah.
kind of close back to what David's original question to you was, which is is the SLS responsible for this performance limitation that drives us to that orbit you just showed? And I think the answer you said is that it's the service module for Orion and not so much the SLS, right?
That's right. Yeah. I mean, everyone would like a full up SLS Mark II or even the Mark III with the upgraded boosters. Mark II has the upgraded upper stage, and that just gives you more performance margin when you want to fly to the moon. But I can't blame SLS for this problem of getting us into a really nasty orbit. Um, Let me see. I'm still here. Yeah. Let's see. I'm going to have to stop share so I get the right prompt.
Okay.
And then I will bring up Griffin's statement and his really good stuff. Is this the Chinese? Yeah, this is his very first illustration is because, yeah, that's right. He was throwing the fear of God into Ted Cruz and company about the Chinese really are serious. They're going to get there. So I'll start sharing and show you uh, this one. And I'll go full screen again if that helps. I think
Okay.
it may in this case. Well, probably not because I have to show a full page. But there is the Chinese architecture. And you can see, yeah, there's rendezvous buried in it. So this is the bat chart for folks that aren't familiar with bat charts that may be out in the general audience. Here's the Earth down here. And time generally flows to the right. And then space to more progressively more remote destination goes upward. And so you go from Earth to low lunar orbit to finally the moon. And the first launch gets you this lunar lander in low lunar orbit where it just sort of loiters. Now, hopefully this lander, I don't know much about it, but hopefully this lander uses storable propellant. So if the second launch is delayed or whatever, that this time interval between its arrival, the lander's arrival in orbit, and the crew's arrival in orbit after the second launch, hopefully that isn't going to cause a loss of performance in the lander's ability to land. But then the crew gets on board the lander. There's a propulsion module that does a deorbit to head for the lunar surface. I don't like these kind of elements that you see here in architecture all too often, where you're going to dispose of something, a propulsion stage in this case, that does a deorbit on the lunar surface. That probably means a hypervelocity impact, which will leave a pretty crater. But remember, this is something that deorbited you and in a polar orbit that repeatedly goes over probably a lot of valuable infrastructure that you have near a pole on the moon. And hopefully, it has, after its crew departs and lands under controlled conditions on the moon, hopefully it has some really reliable avionics that target a spot leading before or after passing over this valuable infrastructure, because every orbit, the moon's turning around on its axis, and this orbit, whether it's nearly rectilinear or not, it's passing over the pole where probably your base is. That's where all the interest is. It passes over the pole every orbit. And so you better have something darn reliable to operate out of that orbit and dispose of this stage and not leave a hypervelocity impact crater on your base or subject it to hypervelocity shrapnel from the impact. But at any rate, here comes the lander finally down on the lunar surface. So you got people on the lunar surface for maybe a week, as long as the Orion based Artemis mission is concerned, about a week. And you did it with only 2 launches and only 1 rendezvous. Sounds like a winner to me, although you may not be able to stay on the moon's surface for as long as Artemis is planning. But getting home is reasonably straightforward, except that you have to rendezvous with what you left there. The second launches vehicle that has your ticket home, the vehicle capable of surviving entry into Earth's atmosphere at 11 kilometers per second. And, that creates problems too, because, as I was saying, talking about the Apollo operations, in this case, we're lucky. We're not dealing with a landing site. The Chinese want to go to the moon's south pole. So every orbit this ticket home makes, it goes over the presumed landing site near a pole. And so you're able to get to that ticket home, but in terms of its ability to depart that orbit and head for the Earth, that is another geometry problem, as all rendezvous have, of actually being in the proper plane. You may have to expend a lot of propellant to get into that plane, or you may have to just sit there and wait, which you have to ask yourself if you weren't safer being on the moon's surface, except, well, at a polar site, you have that luxury. You can just loiter there until the geometry for your ticket home coincides with departure for Earth without a lot of extra propellant or time. And then, it's just straightforward coming home. I'm not sure where this stage is going to wind up. This may be the stage that does trans-Earth injection that starts you on the way back, but it doesn't look like it. It looks like you're just abandoning something in low lunar orbit and then asking it to dispose of itself. And once again, the concerns with hypervelocity impact or just leaving it there in low Earth orbit or low lunar orbit and waiting and seeing where it actually has a hypervelocity impact on the moon, that's just not good, because it could wind up being on top of your lunar base. So that's something to worry about. And then this disposal probably means, your service module coming back to Earth burns up in the Earth's atmosphere. But I don't have an awful lot of insight into this. So that's where we are with the Chinese. The best
It looks a lot more like Apollo, except for the two vehicles, the separate vehicle to get into lunar orbit for the lander and the main capsule. If we call ours lunar orbit rendezvous, we might call this a double rendezvous or something on the way down and then the way back.
Rendezvous in my book of architecture, anyway, even though I love doing rendezvous, it's just bad news. It's not from the architecture point of view. You want to minimize rendezvous, just like in this particular instance where you have a polar base and something in low lunar orbit, operations in low lunar orbit, that every orbit go over that base. That's not a good thing either, especially if you're having to dispose of junk.
So Dan, again, as the non-engineer listener viewing and listening to this show, and for the record, I'm not an engineer, so I'm probably speaking accurately for myself too. Sell me on why you keep reiterating lunar surface rendezvous and why it is rejected.
Well, I'll cite the most common argument against it, and that is there's no way to get home after you depart low Earth orbit. There's no way to get home unless you go to the moon's surface, where all that stuff is presumably cached to get you home, or you wouldn't launch in the first place, right? It's just common sense, right?
Yeah, theory at least.
So you've got all the stuff you need pre-positioned. You're going to verify it's functional and present before you depart Earth. Now, if you don't like that, my counter argument is, what are you doing going to Mars? Because right now, no one has an architecture that once you do trans-Mars injection out of the Earth's vicinity. It might be low Earth orbit. It might be from some kind of lunar based architecture that does an Earth flyby and one of these gravity assist home um, uh, O-berth maneuvers off to Mars. But at any rate, out of the Earth Moon system, once you depart, there's no return abort capability unless you got warp drive. Or I've done some work with a real hyped up thermonuclear propulsion that has like 800 seconds specific impulse, and you can do a return after transmars injection for about the first maybe week or so, but you may have to wait 6 months to get back to Earth because you just don't have enough gas, even with that leap, to double the efficiency of any chemical propulsion we have right now. So if you don't like the idea of no abort out of low Earth orbit heading for the moon in 3 days, I mean, that's not much exposure in terms of time. Then what are you doing considering that even going to Mars? It's way beyond your capability, and you may want some practice like you get doing lunar surface rendezvous before you tackle Mars. So although this may not be the first, and the Chinese would definitely dispute it, the first architecture to land humans on the moon again, it ought to be where we're headed eventually, because then you're running like an airline. So I don't know if that was the most effective argument because it was kind of negative against my own preferred architecture, but it shows how it's a forward-looking architecture. Notice also that in that architecture, and I can call up a crude bat chart that I made for that lunar surface rendezvous kind of profile, a crude bat chart of it, but I think you get the idea. You're just doing 2 launches like the Chinese plan to do, only instead of leaving junk in low lunar orbit, you're going right to the surface with it in both cases. And in fact, you may not, even with the human mission, you may elect to do like you see in 2001: A Space Odyssey, that movie and the book, where you don't go into lunar orbit at all. You don't really light up the main engines until you're doing final braking directly onto the lunar surface. But however you choose to do it, you're not leaving anything in lunar orbit. It all goes onto the moon's surface, where it ought to be readily salvageable and recyclable if you put your mind to using the right materials and design concepts, and no hypervelocity impacts. And get enough of those naturally on the moon, like that asteroid that may be headed there in 2032. Nasty stuff, hypervelocity impacts, especially when there's no atmosphere. So unlike the Earth, you can't say, well, it's it's only 50 meters. We can just write it off. It'll burn up. No, 20 meters could be very, very dangerous in the lunar environment, a 20-meter impact.
Is this more suitable for an evolved and sustainable lunar program rather than trying to get there after 50 years, or maybe for the first time ever? If you're Chinese, maybe you want to take a simpler approach.
Yeah, the Chinese just want to get there, and I don't think a lot of exploration capability is in their architecture. I would love to know how long they think they can stay on the lunar surface, if things are reasonably well behaved systems wise. And does this orbiting hardware, does it have plane change capability that helps you explore lower latitude sites than the poles? Hard to say. But that kind of architecture is not a land anywhere, leave any time architecture in my book.
In your efforts to bring these facts and this information to people's attention, Are you, like some, including what Mike Griffin was doing, both for his congressional testimony as well as on the space show, advocating for a modification in the program of record for our lunar return program? Or is this just information and education for all of us to be well informed?
I I would line up on the latter in terms of, why am I here on the space show? I want the interested public that has some kind of interest or stake in the uh, uh, exploration of the moon and onward into the solar system to be informed. If I could have time with decision makers in Congress and in NASA and help them get up to speed, I would be happy to. But this is one of the few forums available to me to come out and share what I've been learning firsthand through trial and error and experimentation. And that's where I'm at right now. Any uh, any change I would propose to the Artemis architecture will surely come with a delay. And right now, the politics are beat those Chinese to the moon. And we're going to do it. If it means we have to use the program of record with a human landing system that's based on a starship, then that's where we're headed. And I personally don't want to have much association with that. I will follow it with interest. I will reconstruct trajectories to the extent that publicly shared data are available for those trajectories and write reports on that. I'm all excited about Artemis II, but in terms of having any ownership or any buy-in, I'm at arm's length on that.
Um, Comments from any of the listeners here with the program listening?
I'd like to ask, you show the instability of the orbits, and you reference the Earth, obvious, Moon, obvious, and the Sun. Could Jupiter and Saturn and Mars affect the instability of these orbits in certain positions, which is another restriction on when you can launch and do the mission?
No, I think in an operational sense, you would want to consider those other perturbations, not just limit yourself to sun, earth, and moon gravity. But my intent in doing just that was to show, hey, you don't need much to create an unstable orbit and get out of the moon's vicinity. But in coming up with a burn sequence that minimizes propellant consumption and really gives you the best bang for the buck, you want to consider Venus, Mars, Jupiter, Saturn, probably everything you can throw at it to make sure, because where you are particularly at the apocynthion, the high point of that nearly rectilinear halo orbit, you are in a region called the weak stability boundary of the moon's gravity field. And you are exhibiting chaotic motion, even if you're just coasting. And even if you're just ignoring all the other bodies, even if you just consider the Earth, you can ignore the sun, and you have the Earth and the moon tugging on this orbit. It's sufficient to create those instabilities I showed.
And then you add the solar winds, I think.
Oh, sure, yeah. I probably could come up with a crude solar wind model based on all the tracking we've had for Capstone, but it's going to be crude, and plus it's limited by the fact that I don't know how their propulsion system works, and they probably are making a correction every week or two, best I can conjecture. So you have to worry about modeling that in addition to the solar wind and ferreting out, teasing out just what the solar wind's effects are. But you probably could do it.
Mhm.
So
Thank
the
you.
implication of all this, um, one, I guess, if the gateway is going to be in this orbit and it's going to have a propulsion system attached pretty much at all times. It's also going to have to be refueled, or it's going to have deliveries of fuel to it on an ongoing basis. Have you heard anything about that from an operational perspective for the gateway?
Just a little bit. I mean, let me try and clarify what's going to go on. Yes, the propulsion module and power module, I believe, are in the first package to be delivered to nearly rectilinear halo orbit for the gateway. And that propulsion capability will be the most powerful um, uh, in terms of thrust of any solar electric propulsion system flown in space. It's supposed to be really the cat's meow. And because it's solar electric propulsion, and we're talking about really high exhaust velocities, the need to top off the propellant is going to be really an infrequent occurrence. You're going to get a lot of bang for every gram of propellant you consume. So I think there is refueling capability. Um, I'm not sure what the exact propellant is, but it's probably something like argon or neon or something like that. And I've heard some people say that because we're talking liquefied noble gases here, that if the need for propellant is um, greater than we anticipate, particularly with all these hard to predict perturbations that you get with human systems, the dumps and the jettisons and bumps from docking and all that fun stuff that isn't in the capstone uh, mission at all. Um, you could wind up consuming the available supply of noble gas on the Earth pretty quickly, especially if you want to have more of these. Everybody wants their own gateway and all that kind of thing. The the advisable thing to do, from my point of view, is don't even play this game in what is truly a dynamically unstable orbit. To call it stable is misleading the public. And I've caught NASA doing that multiple times. It's not a stable orbit. It doesn't need much propellant, but it needs frequent corrections to any perturbations. And if the perturbations are frequent and of larger magnitude than Capstone is encountering, that propellant consumption could be substantial. Why not
Like it's
instead
also,
say again?
it sounds like it's also at the edge of what a solar electric thruster could provide in terms of thrust.
Yeah, I mean, it can generate a lot of delta V over time. But yeah, all of this stuff is beyond me. I haven't really played any games with it. Um, but to me, the obvious solution is get yourself an architecture that will let you operate out of a circular orbit that has no more than about a 1 day period. So you're talking about something down there around 10,000 kilometers or so from the moon. And then get into uh, a a distant retrograde orbit. And that orbit might be not exactly retrograde. You could get it, into some kind of an inclination. Maybe even get it up toward 90 degrees if you are insisting on landing on the moon's poles. But it may be that you have to do plane changes to get down onto the moon's surface. At any rate, a distant retrograde orbit is really the home for cislunar infrastructure orbiting the moon, because down at that altitude, 10,000, 12,000 kilometers or so, with a 1 day period, you don't need to worry about the instability in the orbit. It's rock solid. It's the reason why many um, distant satellites of outer planets are in retrograde orbits. They probably got captured there from interplanetary space, and they remain there. Once they're there to stay. It's such a stable orbit in spite of being in almost the weak stability boundary. They just stick there, even though the sun's tugging on them real good. The planet is really what counts. And that's, a good example of that. If you want to find one, is Phoebe, Phoebe, the diminutive moon around Saturn that Cassini flew by on the way into Saturn orbit. It's way out there, millions of kilometers out. And it's in a retrograde orbit, almost exactly 180-degree inclination. So that's where we ought to be putting our long-term infrastructure. And indeed, if we want to make cislunar infrastructure part of a larger architecture that goes to the planets and near-Earth objects, that's the closest place to Earth where you can pull that stuff off with one set of infrastructure that'll service multiple missions to multiple destinations.
Dan, when you meet up with a buddy in the general public audience, they know you're a space guy, and they say, "Hey, we're going back to the moon. Aren't you really excited about it?" How do you respond to that?
I am, like I say, I'm excited about Artemis II, even though it won't even go into lunar orbit. And that decision was made, I believe, by Bill Gerstenmaier and his crew many years ago, but with the Artemis architecture in effect, with the constraints on the service module performance, and very wisely so. We have no business taking a vehicle like Orion into low lunar orbit. I mean, it just can't be done. I mean, the crew would be stranded in cislunar space and couldn't get home. So beyond the concern about this is the first time humans will be using their ECLIS systems, their environmental control life support systems, beyond those concerns, with this being a maiden crewed voyage for Orion, you have the flat out inability to reliably, confidently get into this nearly rectilinear halo orbit. And just, it's just what you could do is do a repeat of the, I think, a repeat of the Artemis I mission and get into a distant retrograde orbit 70,000 kilometers from the moon. But this will be a lot more spectacular for maybe one reason, and that is if they can launch such that the far side of the moon is illuminated when they do their flyby, it's going to be spectacular. But no more so than any of the Apollo missions. In fact, they may be quite a bit farther from the moon than 100 kilometers. And also, if they've done that trick with getting into the distant retrograde orbit, 70,000 kilometers farther from the moon than the Earth, I should say farther from the moon than it orbits the Earth, which is exactly what Artemis I did, by the way. You could see at one point the view of the moon's far side with the Earth almost directly behind it. And indeed, they did lose signal with Earth ground stations during that eclipse of the Earth by the moon. Almost certainly, you would set a new human altitude record if they did that. So that's definitely something worth crowing about. Yeah, you'd break the old Apollo 13 record. But with the plan they've got right now, they have to fly by the moon's far side at a very specific altitude that lets them coast right back to the Earth, do a free return. sort of like Apollo 13 set up to get home. Um, and that really depends on where is the moon in its Earth-centered orbit. If it's near perigee in its Earth-centered orbit, flying by the moon's far side probably will not set a new human altitude record. If it's near apogee, yeah, you might.
A couple of other questions that have not come up on today's program. Your thoughts on where we are, or maybe where we are not, with human lunar landers, or with SpaceX or Blue. And I've been anxious to ask you about this sort of temporary fix to Orion heat shield problem by giving it a different return trajectory to Earth that will put less heat and strain on the heat shield before they bring it into the shop and renovate it completely. Those are two areas we haven't talked about. Any thoughts on lunar landers or changing the trajectory to get Orion back?
Well, the human landing system that SpaceX has tied to a Starship is pretty much cast in stone. There's not too much to be done there. I've constantly felt with these uncrewed landings that we've made that keep toppling over that having a high center of gravity at landing is really something to be avoided. We need something that, looks stable, like the old Apollo lunar module, looked like a squat bug, right? It was not going to tip over without a lot of help. So Starship remains a concern. And we need to have some absolutely huge landing gear to look as stable as the lunar module. Blue Moon has some pretty cool options, perhaps. I keep hearing that you can land it with a single launch, and that they'd be stranded, but it could actually accommodate a couple crew persons. And now you're getting very close to lunar surface rendezvous architecture, aren't you? It's like land that sucker with one New Glenn launch. I'm still shaking my head about that, but that's what I've heard. I'll have to try simulating that one. Land a lander with one unoccupied with one New Glenn launch another to robotically refuel it, and then launch a third one to land next to it. And you've got lunar surface rendezvous with 3 launches. I don't know. I don't know how close I'm cutting New Glenn's performance, and how cramped it would be in that lander, but that would be a way to get to the moon on a shoestring. You wouldn't want to spend much time there probably, but that might have some merit. And think of it, you could land anywhere, leave anytime. And that's real exploration, not the stuff that's tied to the pole, not only because of the volatiles that may or may not be there that are, extractable and usable, but also because you need to be flying over that landing site every orbit pretty much with your ticket home. So that's kind of where I am on human landing systems, and it's not really informed, but that's where I am. And then your other question?
The changing the return trajectory for Orion compensate for heat shield problems.
Yep. Yeah, that's another one of those flight dynamics officers, the position I worked in, mission control. That's another one of those FIDO how high questions to the flight director when he says, "Can you get us home?" You're going to do it, but what you're going to have to come up with is a whole bunch of restrictions on when you can launch with that badly mismatched Space Launch System Block 1. You're going to have to make sure that the moon's latitude, and just for the simple Artemis II mission, okay, let alone if you're flying a landing mission, but just for this simple Artemis II mission, the moon's latitude at the time you do the flyby over the far side, the moon's latitude over the Earth tremendously affects what heat loads you will have to endure when you enter the atmosphere. Okay, ideally, what you'd like is the moon to have a northerly latitude, so that when you do the flyby, you come back on the other side of this really elongated orbit that is your trans-Earth trajectory. Starts out at the moon, comes all the way back to near the Earth. In fact, near enough that it gets captured by the atmosphere. So that makes your orbit, which is eastbound, that makes your orbit enter the Earth's atmosphere at a pretty much mirrored latitude. So if you started out north of the equator at the moon, you're going to be south of the equator of the Earth by about the same amount. And so that lets you enter the atmosphere and start doing these role reversals to evenly distribute the heat load, and not having to do a skip out and do a phugoid, if you're familiar with that maneuver in atmospheric flight, where you do a roller coaster basically and then come back in again. This just lets you do a nice, gentle, continuous heating profile as you go back to the California landing site off the coast of San Diego. What they did with Artemis I, and I think it was a smart thing, they wanted to stress the system. They flew over the south pole of the Earth on the way in, and entered the atmosphere, as I recall, over South America or something, and really far south in terms of the inclination of the orbit was, almost polar as they hit the atmosphere. And that just causes much more heat stress, because you're going to have to fly that phugoid to stretch the downrange distance to the point where you splash down where you want to off of San Diego. So this time you're going to wind up with yet another restriction on the day that you can launch with this mismatched SLS, Block 1. And it's going to make it possibly incompatible with setting a new human altitude record. That's the way it goes. You've got only so many constraints you can satisfy, and surviving entry, I would vote for above setting altitude records.
Overall, are you saying or suggesting that we're making an awful lot of compromises that may involve safety as well as technology and sound engineering? I'm trying to figure out how to word it in order to meet a 2028 timeline for getting back to the moon. Would that be a fair summary of your position? I don't want to put words in your mouth.
Yeah, and of course, a lot of it's speculative. I don't have insight into the testing that's going on. What I would say as a pep talk to anybody working in the Artemis program is make sure your risks are calculated ones. Don't pull a we can launch with icicles on the launch pad out of our flight envelope kind of mistake, because you're under schedule pressure. And, it's the old, faster, better, cheaper. You cannot have all three. And we are in a very cost constrained architecture right now. And as a result, the performance is razor thin, especially if you're playing games in nearly rectilinear halo orbit. And you want to make sure you're taking calculated risks. So if somebody's saying, oh, let's launch today because we can set a new human altitude record, and there's a bunch of red lights going off about other constraints that you're pushing to maybe negative margins or certainly very close to zero margin, don't take the risk. This is not a robust architecture.
If you were at the go, no go station, what would you be, and you were still working for NASA, what would you say?
Yeah, I'd be remembering the night before Challenger lifted off with the icicles on the pad. I would be remembering that if I had a constraint to launch that was being violated, I would be standing up and making sure I got to the people that were making the decision.
Well, that
making
was
the best argument I could. That's what killed the Challenger crew, is that the arguments were being made, but management wasn't listening. In other words, they flip-flopped the agreement that's supposed to be between the ground and the crew, which is you have to prove it's safe, not the other way around. And these people were being asked to prove that it wasn't safe.
so. But people are saying NASA's too risk averse. Our space program is too risk averse, and you're an illustration of being too risk averse.
Well, if I was flying with the United Starship Enterprise and raising all these objections, I would agree with them. But I'm not flying with the United Starship Enterprise. I've got a very marginal system. I'm putting to sea in a dinghy. Okay? And the storm clouds if the storm clouds are showing, then I know I'm not going out if I possibly have anything to say about it.
Guys, you're all extremely quiet. Even Marshall's extremely quiet. I can't believe it.
Well, one thing I'd like to raise is with the current program of record for Artemis III, that I presume we launched the Starship lander into this halo orbit before we actually launched the Orion, and then we have to time it exactly so we can get to the point we need to be to rendezvous with that. Is that the assumption?
Yeah, that's right. You're going to want to. I'm sorry now. Yeah, that's right. Okay. Trying to sort out architectures here. Program of record. Where you're going to want to be rendezvousing with the HLS is going to be near the high, such that you are shortly after you do the rendezvous and you get all your, crew transfer and system checkout and all that kind of stuff, and you're ready to start the landing sequence. You are not going to want to be up down near the low point of the orbit. Is that right? Oh, it doesn't matter. That's right. You're gonna want to be at the high point or the low point. So now your loiter time is potentially 3-4 days, that kind of thing. So it's not too bad. I would hope that there's enough propellant margin in the lander that's not going to boil off, because everybody's lander now uses cryogenic propellant, so it's going to be boiling. You're going to be losing performance, and hopefully not too much, because let's remember, you're not going to launch the crew until the lander's on station in that nearly rectilinear halo orbit. And I'm trying to remember, it does. Yeah, I think it has to do that. That's right. So you're going to want to be near an apsis when you get ready to light up, and circularize the orbit eventually. You may have to do it with 2 burns, but you want to get down to something like that 100-kilometer altitude that the lunar module departed from to land. So yeah, you're gonna encounter delays due to launching the crew because there's always the weather, whether it be space or terrestrial. Um, you got to accommodate that after you get on station with the lander, and then you also have to accommodate the day you pick to launch. Well, um, is not when you'd want to start your journey down to the moon's surface. And in fact, you may have a constraint where you're saying, I only want to do my uh, rendezvous near Apocyntheon. I need to have that infrastructure, in this case, the human landing system. I need to have it near Apocyntheon, or my Orion can't get into the halo orbit. So there's all kinds of nasty restrictions, even after you get this fully fueled human landing system in the desired orbit. It's nasty. Love those rendezvous.
Other than improving our knowledge and our own wisdom and our own databases and our critical thinking skills, what the hell are we to do? I mean, there's no place to take this critical input. Do we just, it's like roll the dice. It's like, okay. So I know what you've told me about the slot machines at the nearby casino, but I still want to go to the moon. I still want to go play the slot machine. So what the hell? I'm aware of the risk. I'll probably lose my money, but I'm going to go roll the dice anyway. That's kind of what I personally feel like. I don't know what the others in the room feel like, but it's like, what are we to do? And you're not the only person who's speaking this, but I think you're a little bit more technical and understandable for some of us. But what are we to do? Because we do know we have a timeline and a program of record, and we have some marginal safety and some marginal tolerances in the plan, and yet it's full steam ahead.
Yeah, I like flying Artemis II this year. Got a lot of stuff we can prove, including that we have an operational, or at least uh, a working uh, Orion that can get back from the moon and have the crew survive. And of course, even if they flew the Artemis 1 trajectory, they would survive, I'm pretty sure. Um, but that's a terrible risk to put the crew through. But when you get beyond that to actually attempting a landing, um, I'm going to want to see a lot of really good uncrewed demos of, Starship or Blue Moon, for that matter, landing on the moon and looking really good. And of course, we're going to see a Mark 1 Blue Moon landing this year, hopefully. And all that. But we've got a lot of demonstrating and testing to do before we can fly Artemis 3. And I hope people are patient about that, because it may be well beyond 2030 before we start even considering landing humans on the moon.
If I could jump in on the issue about the program of record, the president's budget request for 2026, I believe, was canceling all the SLS after Artemis 3. And the Big Beautiful Bill extended that to at least Artemis 5. The way I read that is that the assumption is that Starship is going to come along, be successful, and replace SLS/Orion. Do you read it that way? And what are your thoughts about that?
Yeah, it certainly could be what's in the cards. There's certainly the option for that to play out. And I don't disagree with it. But Starship has a lot to prove before we can trust everything to it. So maybe we have an architecture that's once again more like a lunar surface rendezvous that would come out of such an eventuality, right? Where we have this hulking big dumb booster that gets us on the way to the moon in a single launch without any rendezvous and lands a big package there. And some of the time that package includes humans. And it may not actually be that the payload has to be Starship, right? Something that looks a lot more like a lunar specific, a lunar specific lander like the Lunar Excursion Module or Lunar Module in the Apollo program. Why not? So, if you're opening up other possibilities, they might start to get robust and responsible with not a lot of rework. I still think, like I say, that a Starship, because it's built to withstand entry into the Earth's atmosphere at orbital speeds at least, its real mission isn't flying to the moon at all. It's flying point to point on the Earth and maybe getting to low Earth orbit, but can do a lot of resupply that way beyond what the shuttle could.
You didn't mention Mars for its real mission.
And once again, I'm really concerned with its form factor. Its center of gravity is too high, and landing on Mars. Well, let's see if it. Maybe they got chopsticks on Mars and they can catch it. But on the moon, that's not the plan, I don't think. Yes, Marshall.
I have this idea that they take Starship, send it to the moon, very much like you're talking about, with a complete load of supplies and so on. Might even tip it over onto its side and start building a moon base. Mm-hmm. But then I want to add the humanoid robots to do a setup and get things prepared. And do you feel that robots make a big difference?
Huge difference. Yeah. And that's why I was talking about robotic refueling in my pitch about lunar surface rendezvous. But you're talking about something even more fundamental. Let's put some robots up there with maybe some 3D printers and feedstock, maybe the feedstock's in situ research utilization. Mm-hmm. And you can go and create a whole base and keep adding to it as humans start occupying that base. Yeah. Wonderful, wonderful.
I like the idea of a humanoid robot on a little bulldozer, making the roads and setting up the landing pad and paving it over with some kind of glue and, get everything set up. So a lot of the questions about a moon base are taken care of before we send the first people.
Yep. Yeah, that's just fantastic. It's what I'm proposing for Mars and Deimos, for that matter, is that you pre and place stuff with semi-autonomous robots. Now, in the case of the moon, the semi-autonomy can go all the way down to humans in the loop from Earth, right? Because the data latency, if you've got a good dedicated comm system, isn't that bad. I mean, the Russians proved that with Lunokhod. So you can go driving on the moon with humans at the wheel when necessary. But we probably are reaching the point with AI where it's not necessary very often.
Mm-hmm. And I also come in there with the AI. It means that you can come in there and inspect rockets and turn the rockets around and so on like that. So if there is a rare error, fracture, something goes wrong, the robots can find it faster than taking humans in a big bulky space suit crawling around trying to spot the error.
And now you're touching on a theme I've dedicated a good amount of research to, which is low latency telepresence. Even when you um, uh, succumb to the insistence of the public and land astronauts on an exploration destination like the moon, um, you are not going to want to go out there like Mark Watney every day and work for hours, subjected to galactic cosmic radiation and maybe even solar storms and some nasty scenarios. You are not going to want to go out there unless it's a dire emergency. You should be in a subsurface habitat, shielded from radiation, and operating these proxies that are actually doing the in situ exploring. That way, you can work for a full 8-hour shift, hand over to your oncoming counterpart, just like we did in mission control, and work for another 8 hours with that counterpart, all in a shirt sleeve environment, no overhead for EVA at all. And when I was researching this, I actually was working with a multidisciplinary team, some of whom were very familiar with this kind of operation on Earth in remote mining locations, for example, where they, dig, load, haul, all kinds of stuff without a human anywhere in the vicinity. And one of my colleagues was an astronaut, EVA trained, and actually did many spacewalks. And this whole theme of why tolerate this overhead of EVA, was visited with him. And he came to respect that a lot of productivity could come out of that. In other words, you'll get more exploring done if you don't insist on doing it in situ with a spacesuit on. You'll be able to explore better too, because you won't have a helmet with its visors and stuff that are encumbering you. You may be looking through eyes that aren't human at all, to the extent that you're looking in the infrared or some other special narrow spectral band that shows you composition of rocks. You'll be more dexterous than you could ever be with pressurized gloves. Just on and on and on. So you get more exploring done, more cheaply, and with less risk. I mean, what could be more synergistic? I'm sounding like better, faster, cheaper or something here, but that's what comes out of this. It's like, it's so 20th century to insist on exploring off Earth in an EVA mode.
Everyone, we're pushing 2 hours. So if you want to have a final comment or a question or a suggestion, now is the time to speak up. And Dan, if we have omitted something, forgotten to talk with you about something, if you had a really crucial chart you wanted to show us, but you didn't show us, speak.
I don't think so. No, in fact, I'm going to stop sharing if that's all right with everyone.
Yeah, that's fine.
Yeah.
And does anyone have a concluding comment, question, point of relevancy, or anything you would like to add to the conversation today? God, you all really quiet, except for Marshall.
Well, basically, my last question was my last question.
I'd like to say I appreciate you sharing the information that you've simulated with regard to the instabilities around the outer fringes of the NRHO. Very interesting, and I think I got a better understanding of that whole process with your explanation. I appreciate it.
My pleasure.
Yeah, great presentation.
Glad. And, it wasn't really a formal presentation. I may have gotten David concerned about this, but this is the way I love to discuss technical issues and results of my research, is to, have something that's illustrative, which we can now do on Zoom, and then have at it with discussion. That's great.
What are you looking at in addition to this?
Oh, right now I am really fixated on a pet peeve of mine, which is all the new space and even some of the NASA launches are considered proprietary. Their trajectories are considered proprietary. Now, how you design that trajectory may be proprietary. I'll give you that. You can keep your IP concerns in-house there. But the trajectory, I mean, for one thing, you ought to be coordinating it with the known universe to make sure you aren't going to whack into something, right? So the trajectory ought to be out there, but it's not. You rarely can get something made public before the payload's jettisoned. So in this case, Orion, before it's ejected. I shouldn't say jettisoned, but separation of the payload. So I am going to try and build a launch simulator, which I already have. I did one for the shuttle on a Macintosh called the MacMeco. And it basically did the whole powered flight from launch to orbit insertion. Now I want to generalize that with all the crazy equations so that virtually any launch vehicle can be simulated pretty accurately to the degree that they'll disclose information like, here's the dry weight of the first stage and here's the burnout weight and here's the specific impulse of the engines, that kind of stuff. And so I can rapidly reconfigure it for any launch vehicle that's operating and generate the powered flight trajectory and even target it for rendezvous with a specific vehicle, all that kind of stuff. And a lot of good papers will come out of that. And if something's interesting to you and your team here, I'll be happy to share it.
So now you brought up another question because many of those private launch companies are shouting the loudest from the rooftops for the need for rules of the road and space traffic management.
Mm.
So how the hell do you have space traffic management if you will not make public your launch trajectories? Because that would seem to me, again, I'm on the outside looking in. I'm not the engineer or the orbital dynamics guy, but if you keep hidden your launch trajectories, how does that add to having quality space traffic management, which all of these companies say they need?
Well, yeah, I may have overstated my case because they do share those planned trajectories with regulatory agencies such as the FAA.
Okay.
Probably NASA's in the loop, I would like to think. And so those trajectories do get shared. It's just they're not public. And I want to do at least a walks like a duck, talks like a duck fidelity simulation so that I can share, okay, now this is what it looks like launching out of the Cape or out of any location, including the moon. So I've got a system that I can hang this simulation on that would even let me reconstruct, let's say, the Apollo 11 lunar module launch into orbit.
Mm-hmm.
So
Mhm.
it may not be to, uh, you know,
What,
millimeter per second accurate, but it'll look pretty much like it really did in the real world.
aside from curiosity or wanting to know, what is the need to know by the public for launch trajectories if they're disclosed to the regulatory authorities?
Well, one thing might be, and some of this does leak out on occasion. One thing might be, can I see it from New York City or LA? Quite often Vandenberg launches are visible from LA, but you may not get a lot of advance notice. Uh, and similarly, um, uh, visiting vehicles to the ISS go up the East Coast and remain close enough to the East Coast that, weather permitting, you can see them from all the way up to New York City. And that's pretty much where most of these vehicles have main engine cutoff. And then, particularly at night, what is an obvious sighting becomes very difficult to see.
Okay. Closing comments. Anybody want to add anything else?
No.
1, 2, 3. Dan, thank you very much for sharing 2 hours with us on this Sunday. We appreciate it in your work. And yes, when you have more updates or refinements or your new project, let me know and we'll reconvene.
Great. My pleasure, David, as always. Thank you.
Thank you. And to everybody else, keep looking up. And Tuesday should be Bob Zimmerman. If those of you listening have the fortitude to go with it, let's go with it. So goodbye from all. Have a great rest of the weekend. And my best wishes for everyone to have a great week coming up. And thank you again to Dan Adamo. Goodbye, everybody.